What's going on, everyone? Today we're going to be going over my double pass Schlieren system for my Capstone project. We're going to be going over some failures, some difficulties, and ultimately some test results. So the first issue we encountered was an auto dim on the flashlight. So when we were lining it up, the flashlight would dim and we would see this flickering on the screen. But since we weren't all secured in, we were not able to reset the flashlight. This was caused by the frequency of the flashlight and the capture rate of the camera not being in sync. Once the light fixture was bolted down, we were able to reset it, and there was a huge improvement. We can see that some flickering still is present, but it is marginally better than the originals. Here we have a good alignment and a stable flashlight. So this was our baseline test. Comparing with images online, we were getting very similar results to other people's candle test. So we were comparing everything else to this, if anything would be better or worse. Although there is still the odd flicker here and there in this image, it is much better than what it was like on the dim mode, and honestly the best we were able to achieve with our setup. Ideally we would get an arc lamp to get a steady light source. Next I introduced some vibrations onto the table, and we see some misalignment issues start to form here. This blue ring highlighted on the screen, this is the frame that holds the mirror, and it's light reflecting off of that going back into the mirror due to the misalignment. You may see the density gradient come in and out of focus on this imaging as well. That is due to the 2F bouncing around with the vibrations and coming in and off of the knife edge. Since we had a color camera, we purchased some color filters and tried to do some color Schlieren with that as well. However, our best result was still not great with the red and green filters. We were able to see some density gradient, but with a huge loss of clarity. Attempting to overlap the filters to get a transitional zone was a huge failure as well. It was very difficult to tell where the density grade started.
You know, I have one simple request, and that is to have sharks with frickin' laser beams attached to their heads.
So the camera we were shooting with was a digital camera, Sony RX1000, and when we tried with the laser Schlieren, it was just not possible. The camera could not handle the light intensity. Even fully covering the beam up with the laser, it was still not able to handle what little light was still coming through. But on the other hand, since the laser was so bright, it was actually visible to the naked eye. I was able to see the imaging on a flat plane with my naked eye, and I recorded some on my phone just to show you guys that as well. So the system we made was entirely custom built in-house. So just showing up now, we're going to be going over some photos of the apparatus. Right, so this photo here is showing the LED setup without the camera installed. This is the Schlieren laser with the mirror view, and this is what it looks like on the camera's POV. This is the tarp that we set up to protect people from stray rays. Thanks for watching, hope you guys enjoyed.